Welcome to dividing radicals. So some of it is similar to what we did last time when we did multiplying because we're able to just do that same process. So they already wrote it in the one big radical. So remember we like to extend the line. 3 doesn't break down any. 16 is 4 and 4. Oh, that's a pair, so that means it comes out. So I put a 4 down here because it's 16's in the denominator, so my 4 has to be in the denominator. Okay, so I'm almost done, but I have this weird hole right here that I need to put a 1 in. So my answer is 1/4 square root of 3. Hopefully pretty easy. And if you want to try that in your calculator, you can get the same answer. It's a great way to check if you put 1/4 times square root of 3 as square root of 3/16. Just a great little way to check. Okay, so this one, I need to do my big radical. So I have 21 over 3. Okay, so 21 is 7/3. So I'm going to rewrite it. So 7 times 3, and 3 doesn't break down anymore. So I'm able to cancel again like I did last time. So I have a square root of 7 as my answer. And you can check and get decimals. Like, let me show you real quick. So I'm going to do square root, which the square root's right here, right above the word that says log, square root of 21, and I have to get out of the under the bar, divided by square root of 3. And let's hit enter. That's ugly. That doesn't look like what I have, but this is a decimal and this is a nice number. So I'm going to put square root of 7 and make sure they match. And they do, so that means I did it right. Okay, so let's look at this one. So I have numbers on the outside, but that's okay. Wow. Okay, so I have 8 and 4, 48 and 2. Okay, so 8 and 4 can cancel right off the start. So this is 2. 48. 48 is 4 and 12, and 12 is 4 and 3. Oh, I have a pair, so I don't have to go any farther with those, and I can't go any farther with 3. So let's rewrite it. I have a 2 in my numerator on the outside times a 4, because I was able to get that out from the 48. Sorry, it's a little bit cramped. But I have a 3 that I was not able to get out of the square root. And then I have this 2, which I couldn't do anything with. Okay, so far so good. So let's get some new information. If I gave you all the info at one time, you'd be overwhelmed and couldn't do it, even though y'all can do this totally. It's fine. So, no radicals in denominator. It's really in the denominator, but I'm trying to shorten it. You reduce as usual to try to get rid of it. If you can reduce as usual to get rid of the denominator square root, that's fine. That's what we did here. You're done. However, on this one, we reduced as usual, but we still have that square root of 2 in the denominator. And you can't just erase it. It doesn't work that way. Nice try. Okay, so then this one, we rationalize the denominator. And what this means is it's like multiplying by 1. So I have a 2, and remember to get out, I have to have a pair. So I need to multiply this by 2. But I can't just multiply the denominator by 2. Then I have a totally different answer. I have to multiply the numerator also by 2. Instead of canceling, I see this pair, so I'm going to pull that out. So I have 4 times 2 over this 2 that I was able to get out, and then I have 3 times 2, which is 6. So those 2's cancel because it's like dividing 1, it's 1. So I have 4 square root of 6 is my answer. And some of you can do this in 2 steps. Some of you need to see all 3. That's fine. However, you need to solve it, write it down. Okay, so now let's look at this next one. This one only has the denominator and the square root, or square root in the denominator. Wow, so I've put the 12 there, the 2 here, And I'm going to put a 1 just as a placeholder, just because I like to have placeholders in my numerator position, so I don't think I forgot a number. Okay, so I need to multiply this. It is not always 2. The first two examples just happen to have 2. So I need to multiply the denominator by 2 to get a pair. So that means I need to multiply the top by 2. So this pair comes out. So I'm going to have 12 over 2 square root of 2. 12 divided by 2 is 6. So I have 6 square root of 2. Hopefully so far so good. Now let's look at this one. So 3, 7. Okay, 3 doesn't reduce down, like it's 3 and 1, which doesn't help me. 7, also 3 and 1, doesn't help me a lot either. So I need to get rid of it. So to get a pair of 7s, I need to multiply it by a 7. And I have to multiply the top by a 7 also. Don't fall into the trap of doing it by a 3 so you can get that out also. It has to be the same number in the denominator and the numerator. So this is a pair. So I have square root, or I have a 7 in the denominator. I have a 21 up here, and I have this weird hole in the numerator, so I need to fill it in. So I have 1 over 7 square root of 21. Okay, so last one. I'm going to rewrite it as a big square root. So I have 5, 11. Okay, 5 is 1 and 5, doesn't help. 11, 1 and 11 doesn't help. So I need to get a pair of 11, so I need to multiply it by 11. Top by 11 also, because I need it, this number, when I divide 11 by 11, it needs to equal 1. So I have a pair here. So I have square root 11 in the denominator, 55 in the numerator, weird placeholder right there. So I have 1 over 11 square root of 55. And there you go. And that is it. That is rationalizing the denominator. So for homework, it'll be on the board or on the website. Thanks. Bye.